Today's episode is proudly sponsored by the Rising Tide Mastermind. The Rising Tide Mastermind is one of my favorite things that I look forward to each and every week because I get to see people that have my best interest in mind. I know this because I have their best interest in mind. And when you get people together in a room like that, you can just imagine how people want to help other people. If this sounds like something you want to learn more about, go to scalinguph2o.com/mastermind. Welcome to Scaling Up H2O, the podcast where we scale up on knowledge so we don't scale up our systems. My name is Trace Blackmore. I get to host this fantastic podcast, and I get to be part of the Scaling Up Nation. Welcome, Nation. So glad that you are here. And it truly is one of my favorite things to do to bring this podcast to you each and every week. And of course, as you can imagine, bringing a podcast to you each and every week leaves me looking for interesting things to talk about on each and every podcast. Now, several of you have helped me with topics and guests, and thank you so much for doing that. Nation, you may not know this, but you are smack dab in the middle of National Handwashing Awareness Week. Yes, that is a real thing, and it takes place the first full week of every December. And it, of course, coincides with flu season. And one of the number one causes for people getting the flu is somebody touches somebody else that had the flu touched, or probably did more than touch. They sneezed or coughed on it. And then you took your hand and you touched your face, you touched your eye, and that's how that virus can get into your system. So wash your hands and you wash all of those things off. Now, I am a student of washing my hands. I'm not OCD, but I just watch people wash their hands as I'm washing my hands when we're in a public restroom. And I've noticed that some people don't wash their hands. Some people pretend to wash their hands. Some people don't use soap and they just put water over their hands. So I think we all know how to wash our hands, and you are doing yourself a favor if you do it properly. I'm really good friends with a Chick-fil-A operator, and they actually teach everybody in the restaurant to wash their hands with soap and water. They show them how to scrub their hands, and they have to mentally sing happy birthday twice as they're scrubbing with soap and water. And only after they do that, that's when they rinse. So maybe Chick-fil-A can help you with your hand washing. And yes, it was my pleasure to share that with you. If you were at the Association of Water Technologies conference just a few months ago, you might have seen the presentation of Andy Rymeek of HOH share how to dry your hands. This was a TED Talk that he shared with us, and if you want to see this TED Talk, we are going to have that linked on our show notes page. You can get that by going to scalinguph2o.com. And this is episode 341, so we'll have that listed there. But in that TED Talk entitled How to Use One Paper Towel by Joe Smith, Joe explains how much waste goes into our landfills because we don't use one paper towel on average. We use 5 paper towels on average. And just think of all the people in the United States alone, let alone the entire world, washing their hands using 5 paper towels. Now, of course, you're going to go on the show notes page and you are going to watch this TED Talk, but I'm going to give you the Cliff's Notes. So what you do after you wash your hands in the fashion we just spoke about, you are then going to shake your hands 12 times to flick all the water off of your hands, or most of the water off of your hands. And he says, the reason you do it 12 times is because that is the largest number that is a single syllable. So there you go. So you shake your hands 12 times in the sink. And let me tell you, I've been doing this for a while, and a little tip is make sure you're aiming at the sink. Otherwise, you'll get it all over the mirror. And I always feel bad when I make a mess for the janitorial staff to come back behind me. So you get a better technique as you do it. So 12 times you're shaking your hands in the sink, and then you go over to your paper towel. You grab one paper towel and then you fold it, and you use that folded paper towel to dry your hands. And I will tell you, I get my hands drier quicker by using this method. And I don't have time to stand under one of those blow dryers for 3 minutes to try to get my hands dry. This is a fantastic method because it actually saves me time. And while I'm saving time, I'm not wasting paper towels. And if you watch the TED Talk, he talks about how many millions of pounds of paper towels that actually saves each and every year. So think about it. Something that we never think about before. We wash our hands correctly. Hopefully we stay healthier. And now we're going to save time drying our hands. Folks, you never know what you are going to learn on this Scaling Up H2O podcast. As I mentioned, we're going to have that TED Talk on our show notes page. And it's a fun TED Talk. I hope you enjoy it, and I hope the next time you wash your hands, you're a little quicker, you're a little bit cleaner. Here are a couple of events that I want to share with you that are coming up. There's the Rural Water Rally taking place in Washington, D.C. That is on February 6th through 8th. And the Rural Water Rally provides an opportunity for supporters of our industry to make their case directly to their elected officials. So if this is something that interests you, by all means, go to our events page on scalinguph2o.com and we'll have all of that information for you. Another item you might want to check out while you're there is the Clean Tech Forum North America, taking place in San Diego, California, January 22nd through 24th. This is where you could learn from analysts and each other about trends and innovations that are driving the ecosystem forward. So we'll have all of that and more about that conference on our events page. I also want to remind everybody about the Hang. The Hang is one of my favorite things that we do because I get to meet so many of you. So if you will, mark January 11th on your calendar, and we're going to have that Hang at 6 p.m. Eastern Time for exactly 1 hour. And you can find out all the information you want to know and register by going to scalinguph2o.com/hang. That's HANG. And the last one I'll mention is the 2024 AHR Expo. And that is taking place in Chicago, Illinois, January 22nd through 24th. And this is where you can keep up on industry changes that are affecting your business and career, such as AI, controls, decarbonation, plumbing, hydronics, heat pumps, refrigerants, workforce development, business and professional growth, and so much more. This is put on by ASHRAE and AHRI. That is the Air Conditioning, Heating, and Refrigeration Institute. All of that and more, and I mean so much more, because the great staff here at Scaling Up H2O is jam-packing that events page, so you only have to go to one place to see everything that is going on in the water community, and that is scalinguph2o.com. Nation, I am always looking for new guests to interview and teach all of us within the Scaling Up Nation new items that we need to be aware of. And I have no doubt that you are going to enjoy this interview. My lab partner is Richard Beckett of Global Water Solutions. Welcome to the Scaling Up H2O podcast, Richard.
Thank you very much. It's very nice to be here, Trace.
Do you mind telling the Scaling Up Nation a bit about yourself?
Absolutely. Like you said, I work for a company called Global Water Solutions, and I'm the Global OEM Relationship Manager. We're a manufacturing company. We have manufacturing operations in Boston, USA, and in China and in Taiwan. We sell our products, primarily expansion vessels for water systems, both hot, cold, chilled, etc., globally. But I look after all of our large OEM customers.
How did you get into this industry?
Well, many years ago, I worked for a number of different, originally chemical companies who were looking at and were producing something called biocides, which help to clean out cooling towers or get rid of the bugs associated with cooling towers. And there's a natural affinity then to link into the expansion vessel market. I knew the guy, the CEO, Sean Natarajan, I knew him who started the company. I knew him many years ago when he first started the company. And he sort of wanted someone over in Europe to look after the majors. So we just got together and we've had some fun.
Every August, we do Legionella Awareness Month, and there's so many people out there that are just learning about Legionella bacteria and Legionnaire's disease. And there are other people out there that know about it, but they don't know how to discuss it properly or have the conversation with the people that need to make decisions. So I think today's conversation, we're going to be able to bring in some of the things you have to do over in the UK that are very foreign to us over in the States, and talk about some of the things specifically that your company is doing. And I thought what we could do is maybe start out with defining what a dead leg is.
Okay, so basically what we have in a hot water system is the use of a cylinder which will store hot water for use in that building. Whether that building is domestic or commercial, it doesn't really matter. You either have instantaneous hot water or you have stored hot water. If you have stored hot water, then more often than not, you will have what we call a thermal expansion tank connected to that cylinder. And the thermal expansion tank is there just basically to take up the pressure that is associated with the water as it goes from ambient 5 degrees, 6 degrees, 7 degrees, up to 65, 70 degrees stored water. So one particular dead leg, which I'm very familiar with, and I have to say is extremely prevalent, is associated with the thermal expansion tank. And what happens is that plumbers are not forced to connect the expansion tank correctly. They just connect it onto the incoming main next to the hot water cylinder, and then it just takes up the pressure. So it actually does its job. But the problem is there's no water flow. It's almost like in our human terms, it's like the water is breathing. So you breathe in, you breathe out, you breathe in and breathe out. That's exactly what's happening in an expansion tank. And a dead leg is basically anywhere on a water system where the water is not flowing. So that could be as simple as, let's take, a school. Let's take a school where they want to remove one of the faucets, or they want to remove one of the sinks or one of the bathrooms. What do? Usually they'll just blank off the pipe and then remove the faucet. From that blanked off pipe to wherever the pipe is connected, that's now your dead leg. And what will happen in there, if the temperature is correct, you will get microbial growth, definitely. And you might, if you're unfortunate, you will get Legionnaire's disease growing. So a dead leg is anywhere on a water system where water is not flowing. And I'm particularly aware of the dead leg associated with the thermal expansion tank, because these are going in literally everywhere in the world.
Well, let's expand on that. So, can you explain the workings of a thermal expansion tank?
So, a thermal expansion tank is there to, as I said, take up the pressure that is generated from the water that is being heated for use in the building. Now, when you heat water, approximately it will expand by about 4%. And that expanded water, it has to go somewhere. Water is not compressible, so it has to go somewhere. So where does it go? And it goes into what we call a thermal expansion tank. If it's a sealed system, which many, many systems are designed to be sealed systems. So what happens is 1/2 of the expansion tank is full of air, full of just dry air under pressure. And then it's separated from the water system using a diaphragm. And then the water system is connected to the hot water. So the hot water now, as it's going from 5 degrees, 10 degrees ambient water temperature, but just your air temperature, as it's heated up during the day, it gets to around 60, 65, 70 degrees stored water.
And you're talking Celsius for the people over here in the States that are following along.
I am talking Celsius now. So basically what happens then is the water expands by 4%. If you don't accommodate that expanded water, you're going to blow a pipe somewhere. Something on that system is going to give. It has to give because there's that much pressure involved. So what the thermal expansion tank does, it already has a pressure side, and then the water side the diaphragm allows the expanded water increase in pressure to just almost like grow into the air chamber. And then the pressure increases under control and everything is absolutely under control. And that's what a thermal expansion tank does.
And your expertise is realizing that is a dead leg. We are not getting water flow through that system where you could have the potential of growing Legionella bacteria there, and you've created a better mousetrap. Can you talk a little bit about that?
Yeah. So basically, what we have done is, well, just to give you a little nugget of information, it is estimated just in the United Kingdom, 65 million people, 23 million homes. It's estimated that there are about 10 million installations right now which are sat there in dead legs that are now generating microbial growth. Now, the thing is, if you are a human being and your immune system is pretty good, if you get sick, you'll get sick, but then you'll get better. So don't get me wrong, Legionnaire's disease is quite difficult to catch. It's not very, very common because we're not testing for it all the time. It's not like a flu virus or anything like that. So basically, what we have done is we have taken the concept of the thermal expansion tank and we've designed what we call a flow-through device. And this flow-through device fits onto the connection, which goes onto the water connection. And then every single time that the property draws hot water, so draws it down into the sink, into the bath, having a shower, using a faucet, whatever the case is, it will automatically, via the cold water coming in, it will refresh into the expansion vessel fresh water. So there is an automatic method of cleaning out the dead leg. And there are also some engineering shall we say, some good practice engineering plumbing principles which must be adopted to minimize this risk. You're never going to get rid of it. I mean, Legionnaire is a ubiquitous bacteria all over the world. It's in every single freshwater location. It doesn't thrive. Well, it doesn't. It's not in seawater, but it is in all freshwater. And the problem is, we draw that fresh water into our properties. We store that fresh water under pressure and under temperature because we want the water at the right pressure and temperature in our homes and in our schools, our colleges, our hospitals, and our et cetera, et cetera. We are demanding that, and we've created the problem. So we've come up with a very simple solution, very, very low cost, called the flow through, and that will fix it. Problem is, there are no government laws saying you will fit flow through. It just doesn't happen, because that would impinge on the manufacturer's rights to manufacture the unvented cylinder, the hot water cylinder. But yes, we've come up with a simple device.
So you mentioned primarily residential systems, but could these also be put on closed loop heating systems as well?
So the closed loop heating system, this is the heating system, for your listeners, the heating system which is taking the very hot water around in a closed loop. That's not the dangerous loop. That's not a problem. It still needs an expansion tank on it, a heating expansion tank, but that's because it's closed loop. By nature of the fact that it's not potable water or drinking water, it's not a problem. It's only on the thermal expansion. So that's good, Trace. What you've said there is that the closed loop circuit is a completely protected hot water supply circuit, a circuit revolving around the domestic and commercial properties. To get rid of Legionella and to be worried about Legionella, you're only worried about the potable side of it, which is the open loop, because it's open because you have a shower. And when you have a shower, you can only, as I know you're quite hot on Legionnaires, so you can only catch Legionella bacteria by breathing in the droplets. So having a shower, having a spa, going past a fountain in a shopping mall, anywhere which is generating aerosols or small droplets is a potential danger. And I've seen now when around the world, these misting, there are now misting devices which are blowing very fine droplets over fresh fruit and vegetables in the shopping malls and places. And even in restaurants to cool you down in the hot countries. They're blowing over you misted, potentially quite dangerous water.
Now, here in the States, they have this thunder and lightning that goes off in the produce section to warn you that it's getting ready to mist the produce. Is that something they do in the UK as well?
Well, they don't warn us. It just mists it. They mists it. I mean, obviously, the smaller the retailer, the smaller the grocer, the bigger potential. The big supermarkets, then clearly, I would hope that they are doing the correct dosing regime and they have the correct. But I'm pretty certain that they're not, because we also, as a company, we manufacture very large thermal expansion tanks up to 10,000 litre. And I know for certain, I know 100% that a lot of these are sat in dead legs. And these are going into hospitals, schools, where in a hospital, the immune system of a patient is compromised anyway. So it's a big problem. And there are guidelines. There are recommended guidelines around Europe. And I'd be amazed if there aren't guidelines in the States as well, recommending, but only recommending, how plumbers should deal with the thermal expansion of hot water systems. I believe there are recommendations. And what I would love to do is move the conversation forward so that turns into not just a recommendation, but an actual requirement. And it wouldn't be difficult. In UK and Europe, we have things called L8, which is a law, which, you have to do certain things when you're putting in a domestic and commercial heating system and cold water and potable system. You've got to do it in a certain way. I think we should just add in there the fact that flow through should be a device. And we're not the only company, by the way. I mean, I'm not just blowing our own trumpet. There's not many. There's only a couple of companies. So, but let's get it out there and let's install these damn things, because it's really important that we protect the consumer and the public.
I will say from my experience, the States is way lagging behind any legislation. If we look at the UK, if we look at Europe, we look at Australia, New Zealand, they have a lot more legislation regarding Legionella bacteria and trying to limit Legionnaire's disease.
You see, what's happened, and is happening more and more, is that now the insurance companies have now tagged onto this. And we've now got what we call ambulance chasing insurance companies who are making a lot of money on people, unfortunately, who have either gone on holiday into hot countries and come back and have contracted Legionella. It takes about a fortnight, 2 weeks to actually for it all to populate and colonize and then start to affect you. So this is also driving the topic to the forefront of people's minds, because our health authority, or our health industry over here is run by what we call the National Health Service, NHS. And the NHS is being sued all the time. We have lots of different pockets of NHS, London, Edinburgh, Glasgow, Manchester, Liverpool, they're all different NHS, but they're all under the umbrella of the NHS, and they're getting sued. They're getting sued because they are the duty holders in a hospital or a school, and they are not looking after the public because they are not insisting on the correct equipment being installed correctly. But it still isn't law. And in the States, if you're lagging behind, then basically what's happening is people are getting sick. And I don't know whether the insurance companies are catching up, but boy, oh boy, they will do. And it's huge business just on the insurance side of it.
In a Legionella prevention program where people are implementing testing, say they're testing their hot water system and they're trying to figure out where the Legionella is coming from. In your experience, as they're tracing the system, what's the percentage that's coming from this thermal expansion tank?
There are no statistics. So unfortunately, I can't give you, and I won't estimate it. But suffice to say, when we have done our research with the facilities management companies who look after all of these, and we'll say commercial properties now rather than domestic, but on the commercial property side, so schools, colleges, nursing homes, daycare centres, sports halls, etc. And these are the larger tanks. These FM companies are going in there and they are replacing failed tanks. Okay, when they replace the failed tank, the microbial growth that is within the tank that is being taken out is so dangerous they're having to mask up. It's unbelievable. A bit like when you see it on your shower head. If your shower head hasn't been cleaned for a long time, you'll get black. Usually, well, it's always black deposits. That's microbial growth. And within that could be Legionella. So the percentage is very difficult to ascertain, but definitely it is coming from, there will be a source coming from the thermal expansion tank. And people need to be aware of that, and people need to be asking the plumber to install the flow through and install it correctly. And at the end, and certainly as part of this podcast, there will be resources that we can give you, the listeners, to go to find out where they can get the devices from. Because like I said, they're very low cost. You're not having to rip the whole system out and put a new valve in. It's not like that. It's a very, very simple device. But yeah, it's a considerable problem. I know that for certain. And increasing, by the way, Trace, because if you go to in Europe, there is they're monitoring this now. There's a Legionella monitoring disease for centre control, a bit like the States. And they have all the statistic. Every government have to publish the statistics every single month. So you can look at what's happening. And the detection rate is increasing. The numbers are increasing. And unfortunately, the deaths are increasing. It's really bad.
You mentioned proper installation. I know each area has their own building guidelines on how they want things installed, but generally, how are these most commonly misinstalled?
Because for decades now, the expansion tank, which is a very, very old technology, because it works, the expansion tank has been connected to the cold water supply to the unvented cylinder or the hot water cylinder using the pipe, using a 1 inch pipe or inch and a quarter or 25 mil if it's in metric, etc. And so long as there is nothing in between the thermal expansion vessel and the hot water cylinder. So in other words, the water, when it expands, can expand into the thermal expansion tank, then there's no problem. And it will do its job. So in other words, the homeowner or the commercial property owner won't see any problem. It'll just carry on working all day long, all night long, no problem, week in, week out. The problem is, like I said at the beginning, the water is just breathing. It's like expanding and contracting every day. So it expands once in the morning and then expands and contracts every time water is drawn from the hot water cylinder. But that's not water flow. The only flow is coming along the incoming water pipe straight into the hot water cylinder. So the dead leg now is all the way up the pipe. And this pipe sometimes can be 3 or 4 meters away from the thermal expansion tank. And it could be an 18, 24, 35 litre tank. So a 35 litre expansion tank, this is on a sort of semi-domestic or large house. A 35 litre tank will have 17, 18, 19, 20 litres of water in there, plus the pipe, which is going nowhere for the life of its installation. So we're now talking, 25 litres of water at the right temperature, above 22 degrees and below 50 degrees, say, with a nutrient source, which is unfortunately the rubber membrane or the diaphragm inside the actual expansion. That's the nutrient source for the bacteria to grow. So it's it's like a little microbial farm, a farmyard. We're growing the damn thing. So that's where we are now. And that's how the installations are being installed right now. And the problem is, engineering-wise, plumbing-wise, fluid dynamics-wise, everything's working. Microbial-wise, we have a problem here.
So you mentioned hospitals and schools and office buildings. How large do these systems come in? Is there a limitation to these flow-through thermal tanks that you can only go up a certain size?
No, not really. Not really. I mean, some of the biggest installations, biggest hotels in the world, the heating systems are the way I've described them. So they're either instantaneous using plate heat exchangers, which do away with the problem. But the problem with that they also have other issues as well. Or if they have hot water storage, then the thermal expansion tank with flow through can accommodate it. And we do up to 450 litre flow through. But if you need double that, you just put them in parallel. So, there's no issues with that.
Let's arm the Scaling Up Nation with how to have the proper conversation. So I will admit the thermal expansion tank is something that I rarely thought of, but you're right. It's a dead leg. It's harboring bacteria. So now we're going to be more cognizant of that. What should we be saying to our customers to help educate them?
Well, the customer, when they're having a heating system installed, and I'm now talking about, I don't care whether it's a domestic customer or whether it's a school governor or whether it's a hospital or a dental surgery or whatever. The question has to be posed to the plumber. Are you fitting my hot water with anti-Legionella device? Now, probably the plumber will just go, oh my goodness, I don't know what on earth are you maybe they've heard about Legionella, but they will certainly have to do some research. Now, what will happen then is the plumber will have to go to their supplier, the merchant, and then ask the question. And all of the manufacturers, they all know about these devices, but because historically they've not done anything about it, they aren't going to do anything about it now. But they can get hold of them. Like I said, there's only a handful of companies who are manufacturing this type of device, the flow-through device, but there are a handful of manufacturers who are doing it. And they're in the States, and they're in Europe, and they're everywhere, all over the globe. So we're all over the globe. Our flow-through tanks are manufactured in Boston, Massachusetts, and we ship them all over the globe. And they have all of the relevant certification, and they're approved for drinking water, etc. So there is no reason whatsoever why everybody in the States, everybody in the world should not be fitting these things on every single hot water system. So the question needs to be asked when you're getting a price for your hot water supply. I don't care whether it's domestic or commercial, please install anti-Legionella flow-through. That's it.
Now, how does that answer change when we're talking about retrofits?
Well, it's a bit more difficult. It's already in there. They have to isolate the the thermal expansion vessel. Probably the hot water supply system will have to be isolated because there won't be the correct isolation valves to allow the building to be online permanently while you're doing this retrofit. But unfortunately, yes, they're going to have to isolate the building, drain the system down, and then fit the correct device because it's a retrofit. And the device is a flow-through expansion vessel. Yeah, absolutely. There's nothing we can do about that. And then bring it back on. But it shouldn't take long. I mean, if it's a commercial premises, if it's off for half a day, I would say that's probably maximum.
I'll make sure that we have some information on our show notes page so people can actually see the diagrams of how these work.
We have very good videos showing people what is actually happening inside the tank. You can almost see the growth occurring. It's a bit morbid, but it's there.
What's the one message you want to get across to our listeners more than anything else?
Start talking about it. Every single person that's at home and going to a sports hall, having a shower, going to the swimming pool, having a shower, going to hospital, a dental surgery, etc. Listen, if they're delivering hot water into these buildings, potentially they're also delivering microbial atmospheric growth, which is potentially Legionella. This is not good. So start talking about it. Educate yourself. Get on the internet. It's all available, because until we drive this subject more and more to the fore, it's always just in the background. And the ultimate goal here is for the hot water cylinder people, the manufacturers, the people who are manufacturing the hot water cylinders, the storage cylinders. It's really incumbent on those people to supply because they nearly always supply the thermal expansion tank along with the hot water cylinder, the hot water storage tank. It comes hand in hand. Just to be cheap and just to make it really simple, they should be demanding that the homeowner, the duty holder, should be demanding that they fit a flow-through expansion vessel device along with the actual thermal expansion tank. So that's what has to happen.
Well, Richard, I want to thank you for coming on the Scaling Up H2O podcast and getting us to think about all parts of the system, not just little stubs, little dead legs that we normally think of, but also the thermal expansion tanks. I think you've helped a lot of people in their thinking, and I think that's going to help a lot of people not get Legionnaire's disease. Thanks so much for coming on the show.
You're welcome.
Scaling Up Nation, some of our most downloaded episodes take place in the month of August, where we do Legionella Awareness Month. That tells us that there's so many people out there that just want to learn more about Legionella and what their responsibilities are. And we're always trying to bring you, the Scaling Up Nation, more information about that. But I have to tell you, I have never thought about expansion tanks. Of course, when we do surveys, we kind of list those, but we don't really have any alternatives for them. So when I saw this, I knew I wanted to bring this to the Scaling Up Nation. So if you want to learn more information about what Richard was sharing with us, we're going to have lots of information and links on our show notes page so you can better educate yourself. And we are now looking at the system in its entirety, and that's what we want to do each and every time we look at whether it is a domestic water system or it is a hydronic system. We want to make sure that we're looking for every potential area where we are not getting water flow. Now, a dead leg is described as anything that's longer than 3 inches. So I don't know if you've really thought about that in terms. 3 inches is not very much. And when you think of systems and how things get abandoned, maybe sinks get abandoned, maybe pieces of equipment get abandoned, and they just simply valve or cap off that line, well, that is a dead leg. And that's something that we need to look into each and every time we do a survey and see what we could do to eliminate that dead leg, get some flow through it, or maybe we can just cut that pipe out altogether. But that's one of the things that we want to do when we're doing our inspections. Now, something fun to help you remember dead legs is our friend Detective H2O. Here he is.
The Case of Seeing the Dead. As he stood looking out the rain-spattered window of his office in downtown Waterville, Herbert Henry Oxidane, P.I., CWT, cracked a sideways smile when his black rotary phone sprang to life. On the third ring, he answered. Detective H2O here, the best water treater this side of the Ohio. Solving water problems drop by drop. What you got?
Mr. Detective Oxidane, or H2O, whatever your moniker is, this is Charlie Baxter, originally from Savannah, Georgia, but I now live in Waterville and I work at Carlisle Industrial Incorporated. I got your name from a friend, and I thought I'd drop a dime on you.
I see. Well, since you got me on the blower, why don't you spit it out? I charge by the minute.
Paying cabbage is no problem if you can come on out here and solve our problem. We have this process loop, you see, and it keeps getting loaded up with those microbial critters. I tell you what, despite all our best efforts, why don't y'all come on down here and I'll give you the full scoop.
All right, you've hooked me. I'll get my rust bucket started and be out your way within the hour. I might have to fill up the old mare first since you're uphill most of the way, and she gets mighty thirsty in her old age.
Fantastic, Detective H2O. We'll be ready for you. Y'all come on down, you hear?
As if on demand, the deluge of rain slowed to a light drizzle as Detective H2O pulled to a stop in his rusty blue Ford. Water was in his blood, and weather like this always soothed his soul. Charlie Baxter met him at the front gate and escorted him to his office in the middle of the plant. The detective had never been here before. A multinational water treatment company had this account buttoned up for years. It was telling that he was being invited here now. Something had them perplexed, and solutions weren't forthcoming. This is quite the complex operation you have here, Mr. Baxter. Pipes running everywhere, from every direction, it seems. Some water and some not.
Oh, please, call me Charlie. And what should I call you?
Detective H2O, was the bland reply.
Oh, of course.
Charlie quickly recovered.
You are quite right, Detective H2O. This facility looks like a bowl of spaghetti. In fact, people accuse us of getting Willy Wonka to design it. Every nook and cranny has a purpose to get the final product out the door. But it ain't an easy task keeping it all going. And you can take that to the bank.
Tell me about this process loop that's giving you the headache that you mentioned on the phone. Charlie looked out at the facility and said,
You see, the main process loop provides cooling water to several critical processes in the plant. It's a completely closed loop, all clammed up with no open water to the atmosphere. We had some failures in some piping and even a heat exchanger. Upon inspection, all the reports said MIC, or microbiologically induced corrosion, that is. This comes as no surprise since the metal samples we took even felt slimy.
I see. What did you do next? You mentioned taking action on the phone earlier.
First, we tested the system for microbial activity, and boy, did we find them. Then we added a non-oxidizing biocide. That seemed to ward them little suckers off for a while, but they soon came back. We tried a few more times, but it was the same old story. It was like a broken record. Then we moved to an oxidizing biocide, and we flushed the system before and after we added that biocide. That's not an easy task with a loop this large. Plus, we had to add fresh water treatment chemicals. Those critters came back again. Sometimes you can even smell those suckers in the water. Just over a month and a half ago, we repeated the oxidizer, drain, and flush again. And of course, we had to put new water treatment chemicals in too. You can probably guess what happened after that. They seemingly returned from beyond the grave to resurrect themselves once again. That's where you come in. Our experts are out of ideas,
Charlie said, dropping his head. The detective eyed the poor sap and replied, "Well, you've got quite the story to tell there. That's a lot to take in, but I'll do my best to get this canary to sing. First, what is the chemical treatment program you use in the main process loop?"
Nitrite. Now, I know where you're going with this because we continually see our nitrite levels drop as them bug counts keep going up. That's why we also did a pre-flush prior to adding the oxidizer, since we didn't want the reaction between the two becoming part of the oxidizer demand.
Yes, very good. Nitrate can be a bug food, and we'll take that into consideration. Nitrite is an excellent corrosion inhibitor and is used successfully in all kinds of applications without the issues you are experiencing. We won't discount its impact, but let's get the lay of the land first. I need to see your testing logs, disinfection reports, and whatever other details you can show me regarding the actions you've taken.
We're an open book around here, Detective. It's already laid out on that table over yonder. Y'all going over there and help yourself.
As Detective H2O perused through the files, he took notes, pulled out his near abacus calculator to confirm a few things, and peppered Charlie with questions. Anything Charlie didn't know, he pulled his guys in to answer. "Charlie, procedurally, I can't poke holes in your story. It does appear the disinfections were by the book with enough oxidizer for enough time throughout a multitude of checkpoints in the system to be effective. In most applications, it would have worked. There's more to find out, though. Can you walk me through the system next? I want to see everything from where the makeup water comes in to the pumps, heat exchangers, side stream filters, chemical addition points, vents, and drains."
Not a problem. And I know where to just start this little trip. Y'all come on now, you hear?
Charlie took Detective H2O through a maze of piping, stairs, and aisleways. All the time, the detective kept his eye on the main process loop piping and sketched a process flow diagram as they went along. They tracked down every T, opened the pot feeder, inspected the bag filters, etc. As they stood at what Charlie said was the end of the road, Detective H2O glared at his hand-sketched process flow diagram and said, "Okay, this is the last jump-off point from the main line just above our heads. It's the same diameter as the primary flow of the main process loop, quite large. Where does it go?"
Well, that's there for future expansion plans so we can connect those operations to the main process loop. It ends just beyond that wall over there.
"It ends, you say? Can you show me?" Charlie led the way through a door into the next room where the piping simply ended with a blind flange. Peering up at the stunted piping, Detective H2O knew he'd found what he'd been looking for all along. "So tell me, Charlie, when you did your disinfection, draining, and flushing of the system, did you do anything special with this part of the piping?"
Well, no we didn't. As a matter of fact, I really ain't getting it no mind until you just brought it up right now. I'm sure it drained with the rest of the system.
Detective H2O gave his trademark sideways, slightly unsettling smile and proclaimed, "That's a dead leg, my good fellow."
A what? A dead what?
A dead leg. Not a zombie apocalypse, but an area within a system with low to no flow. It can be a leg of piping dead-ended like this one, or even an offline system, such as a chiller. Not only can sediment slowly collect in these areas, but so can microbiological activity such as biofilms. Because of the lack of sufficient flow, water treatment chemicals cannot reach far enough into them to be effective. The bugs set up home in these dead legs, safe from your biocides and disinfection activities. Each time you tried to clean the system, they simply waited and re-inoculated the bulk water all over again. I believe this is our smoking gun.
Ooh-wee! A dead leg. Who'd have thunk? But what you say makes sense. I tell you what, I'm tired of taking the fall for these little guys. What can you do about it, Detective?
In your case, I think you need to disinfect the system one more time, unfortunately, but this time the entire system. If you can't remove the whole dead leg, you'll at the very least need to install a drain line at the end that you'll have to open on a regular basis to establish flow, remove any sediment, and expose the piping to the water treatment. Plus, I'm curious to see what's inside the pipe. It will need to be cleaned out. Let's walk the system again to make sure we're not missing any other such dead legs. And then I'll work with you to develop a plan for a thorough disinfection this time.
All righty then. Let's get started. We'll have them critters sleeping with the fishes before we know it.
1 month, 2 months, 6 months, and a year later, Charlie Baxter called Detective H2O to give him an update on the main process loop. There was no noted microbiological activity. Detective H2O had saved the day once again and was paid all the cabbage he was due. In the underbellies and penthouses of the metropolis of Waterville, where the boilers percolate and cooling towers fog, there is one man who works tirelessly to end corrosion, stop scale, fight low-life microbes, and conserve water. That man is Detective H2O, best water treater this side of the Ohio, solving water problems drop by drop.
I love that James puts those together, and I love collaborating with James, and apparently the only accent that I can do is somebody from Savannah. James gave me fair warning for next year. I am working on a new accent, so hopefully my accent chops will be a little bit more up to par when you hear that next year during Industrial Water Week. And if you're wondering, Industrial Water Week is going to be the second week of October. We're going to be celebrating October 7th through 11th. So mark your calendars so we can all celebrate together. Not only are you going to get a brand new episode of Scaling Up H2O each and every day that week, you are also going to hear a brand new Detective H2O. Nation, if you want to learn more about what you need to know to do water management plans, i.e. doing surveys on systems, i.e. finding dead legs, I cannot recommend more about getting your ASSC 12080 certification. There's so many wonderful courses out there that actually go into what you need to know and prepare you for answering questions with your customers and doing that survey that we keep talking about. Well, we heard from James McDonald once. We're going to bring him back one more time. Here's Periodic Water Table with James.
Hello and welcome to the Periodic Water Table with James, where we think and learn about water chemistry drop by drop. Please use your week to search online, ask your colleagues, or even pick up a book to learn more about each week's periodic water table topic. If you do, at the end of the year, you'll be 52 water chemistry smarter. So let's raise the water table of knowledge together and get started. Today's topic is Barium. What should you do with all my chemistry jokes? Barium. How could barium cause issues in a water system? Does barium combine with carbonates, sulfates, or other groups to cause potential problems? How do you test for barium in water? Have you analyzed a water sample for barium? At what concentrations could barium cause issues? If barium is an issue, what tools do you have available to control it? Remember, knowledge is power, and taking the time to learn more about water chemistry each week will help make you a force to be reckoned with. Be sure to post what you learned to social media and tag it with hashtag WaterTable23 and hashtag ScalingUpH2O. I look forward to learning more from you.
Scaling Up Nation, when I was at the Association of Water Technologies conference, the number one question that I received was, how do I get caught up with Periodic Water Table with James? Well, we made that easy. We have links on our webpage so you can go back and see each one of those challenges. Of course, we would love it if you listen to every episode that we aired this year and listen for James's challenge. But either way that you do it, we have got you covered. And that way you can be 52 times smarter by the end of the year on the chemistries that we work with each and every day. Nation, I truly enjoy bringing this show to you each and every Friday, and we're going to have a new episode for you next Friday, as you've come to expect. And if you have an idea of something you want to hear on the Scaling Up H2O podcast, please let us know about that by going to scalinguph2o.com, going over to our show ideas page, and letting us know that information. Something else you can do for us is the next time you are on your favorite podcast player, go ahead and leave a comment about this podcast. That helps us get a little bit higher in the ranking, which allows people to find us a little bit easier. And every time we get a new member within the Scaling Up Nation, I truly believe that we not only expand our community, but we help raise the bar in the industrial water treatment community. And that's what it's all about. We want to leave everything that we touched a little bit better than when we found it. And we are all helping make that happen. Have a great week, folks. Scaling Up Nation, it's my hope that whatever you do in the industrial water treatment community, that you do it with excellence. And if you're in the same type of water treatment that I'm in, I do that by maintaining my Certified Water Technologist designation. I know so many of you out there are studying for that prestigious certification, and I'm here to help. I've answered each one of the mock exam questions, letting you know the logic behind how questions are asked, and also doing all the math to show you how to set things up so you can easily find the right answer and make sure you don't select one of those sneaky wrong answers. Go to scalinguph2o.com/CWT prep. Again, that's scalinguph2o.com/CWT prep to sign up today.